Hello children, let me explain some examples. Okay, page number 90, you can see the first question. Apparent depth of a liquid is given, which is 15 centimeter, and real depth is given this centimeter. Find the refractive index of the liquid. The question is that. So refractive index formula you know is equal to the real depth by apparent depth. Put the value of real depth over here and put the value of apparent depth over here. You can easily find the refractive index of the liquid by this formula, which is very easy, 1.33. Okay, so second question we have a point source C. We have a point source, the figure is also given in the question. O, there are two rays which is passing through this. As the first ray is incident normally on PQ, and this is therefore passed undeviated like this, and this ray strikes on the first surface, gets refracted towards the normal, again bends away from the normal. So here the two reflection is taking place. So this is the figure which is given. The first question says, in the diagram, label the position of the source, position I of the source O, where it will appear when seen it through the surface RS. Okay, the question says, where will be the position of the image of this O? Okay, where will the position of the image of this O if I see it through RS? So how to find that? It is very easy. You have to produce, this is RS, so this ray you have to produce backward, make a straight line where this ray meet at this line. That's the position of the image I if you see it through RS. So like this. So this we are seeing it through RS, we have to produce it backward by this dotted line. So this is the point, this is the position of I where the image of this O will be seen if I see it through RS. So first question answered. Second question, does the source O appear to be nearer or farther with respect to the surface PQ? Obviously this I is closer to PQ, therefore it will appear nearer. How does the shift depend on the thickness PS and QR of the slab? PS or QR, how does it depend? As you know that the more is the thickness, more will be the shift. So yeah, if thickness is less will be the shift. Okay, so if thickness decreases, shift also decreases. How to justify your answer? Justify your answer the option. So now let's take instead of PS, let's choose PS prime, which is less thicker, no? So obviously the shift should decrease. Shift is this value, initially the shift was OI. Okay, initially the shift was OI with considering this thickness PS. Now if you choose PS prime, which is less thicker, then if you choose PS prime, then if you see it, this is the, if you choose PS prime, then what will happen? If you see it from this SR prime, then the ray, if you produce it backward, alright, the ray which we are producing backward appears to come from I prime. Okay, you can see that the ray diagram is shown in figure in which for the thickness PS the image is at I, while for the thickness PS prime the another emergent ray parallel to the given previous emergent ray is drawn and the image is at I prime. So if from here, from SR prime, if I draw another emergent ray, which should be parallel, okay, because this ray should go like this, no? If you draw a parallel ray, then it is coming at I prime. So if the thickness were this much only, then this would have been the emergent ray. So if I produce it backward, then I prime would have been the image. So I prime would be the image. So what will happen to the shift? So OI prime is bigger or OI is bigger? Obviously OI is bigger, so shift decreased if it decrease the thickness. So this is how we justify the answer. So for which color the shift will be maximum? Obviously violet, because more is the refracting index of the light, more is the shift. So violet has the more refracting index, therefore it will be maximum for violet. Similarly, the other questions is given. We have a glass slab is placed over a piece of paper on which the Vipcure is printed on with each letter into its corresponding color. We have Vipcure which is printed, and glass slab is placed over Vipcure. So will the image of all the thickness be in the same place? No, the image of the same, all the letters will not be in the same place. Why? Because we know that the letter of which color will appear to be raised. So as we know, the shift will be maximum for the violet color, and therefore the letter violet will be raised maximum, and the letter red will be raised minimum. Why? Because red color has least value of refractive index. Therefore this will happen. Is regional apparent depth equals to depth by refractive index. Refractive index of glass is most for violet light while least for red light. Therefore the apparent depth is least for the violet letter and most for the red letter. Yeah, this is how you can understand. Apparent depth will be least for the violet letter, the most for the red letter. Therefore this violet will be, violet color appears to be raised maximum. Number 4. We have a coin which is placed inside the water of refractive index. This, when viewed from air in a vertical direction, okay, appears to be raised by 2 meters. Find the depth of the coin. So shift is given, which is 2 millimeter. Refractive index is given, and find the depth of the coin in water. So we have to find the depth, real depth. Okay, so let's say real depth is x millimeter. Apparent depth is, if you know the real depth, then there's a formula for apparent depth. No, apparent depth equals to real depth divided by mu, refractive index. So x mu is 4/3. From there we get apparent depth. So shift equals to real depth minus apparent depth. Shift we know, shift we equals to 2 millimeter, and the real depth is x, then apparent depth is 3/4x. Here we got shift equals to x/4, so x/4 equals to 2. From there we get x equals to 8 millimeter. So depth of the coin in water will be 8 millimeter.